Greetings, welcome to Lab 2 Part 2. Working with normal distributions, but this time we're going to talk about the z-score. So in this exercise, we're actually going to be doing exercise 3.3. We're predominantly going to be talking about the z-score. So a quick review of what the z-score is all about. The z-score of an observation is the number of standard deviation that falls above or below the mean. We compute the z-score for an observation x that follows a distribution with mean mu and standard deviation using the following formula. Now, there are very few things in this class that you're going to be asked to memorize, but this is one of them. You're going to need to make sure you've got this one top of the head, okay? So in your comp book, yes, very important, put that in your reference book, but you should also have this top of the head, okay? So a couple of things just to make sure you understand what it's actually doing here with this particular formula is that notice what you're doing is you're taking your data point or your observed data value. That's this value right here. That's your observed data point, and what you're doing is you're subtracting the mean from it and then dividing it by the standard deviation. Okay, so let's open up a fresh whiteboard real quick and let me show you what that would look like. Okay, so what that means is this. If we were to draw ourselves a number line here and we put on the number line here mu, and then we say over here this is the value of x, then the distance between those two values can be calculated to be x minus mu. In other words, the distance from there to there is x minus mu. And so then what we ask ourselves is we want to know is, looking in this interval between here and here, between these two, how many standard deviations can we stuff in there? I mean, how many standard deviations will fit in there? So how many SDs fit in that interval? That's what we want to know, okay? And that becomes our metric. In other words, what a z gives us, it gives us the number of standard deviations that we're able to fit between those two. So z is equal to x minus mu, the difference between our observed point and the mean, divided by the standard deviation, and that gives us back the number of standard deviations that x fell above or below mu. That's an x there, actually. There we go, looks like an x. Either above or below, depending on whether the sign of it, the sign of z is going to determine that. Okay, mu for the mean. All right, so let's go back to our page here. So a couple of quick things down here. So if we're working in this particular chapter on the normal distribution. Think about z-scores is they work independent of any distribution. They're not it doesn't require to be a normal distribution to calculate a z-score. It still will give you the position above or below the mean in units of standard deviation. Okay, so if your mean is right here, which it will be in a standard normal distribution, or if that many any normal distribution, because it's bell-shaped unimodal, if you have a negative z-score, then that means your observed value x fell below the mean. If you have a positive z-score, again, okay, so right down here, that's mu again, and then this point over here, that's x. If you have a positive z-score, then that means that your x fell above the mean. Okay, well, with that little bit of review, hopefully all that sounds real familiar because you guys did read the book, right? Let's get on to exercise 3.3. So we're going to get over to RStudio for that because I've already gone in and preloaded that exercise into the RMD that we were working on in part 1. And we get to here in part 2, we're going to start working on exercise 3.3, which says scores on a GRE. Part 1 of that, we're going to actually do two problems, 3.3 and 3.5, both have to do with this scenario. So a college senior who took the graduate record exam scored 620 on verbal reasoning and 670 on quantitative reasoning. The mean score for the verbal reasoning was 462 with an SD of 119. The mean for the quantitative reasoning was 584 with an SD of 151. Assume both distributions are nearly normal. So for these folks who don't know, the graduate record exam, you can think about it as sort of analogous for when you finish your bachelor's degree. If you want to go on to graduate school, It's kind of like taking the SAT again, one more time, but even more intense to decide whether or not they're going to accept you into the particular grads program that you want to get into. All right, anyway, so what they want us to do, the first one is use our shorthand notation for normal distributions for these two. So let's say we'll put VR for verbal, okay? So that's going to be, I'll put an arrow in there. So the verbal reasoning normal distribution, that was the first one they gave us here. And we had a, let's take a look at the mean score for verbal reasoning was 426. So it's going to be N, it's going to be 462. N of 462 for our mean, and a standard deviation of 119. Okay, so I'll put a comma here. Oh, by the way, I want to go back up to my previous line just to make sure. RStudio, the markdowns files, to get a line break, they'll kind of flow into each other unless you put a double space at the end of your line. So if you want to keep your lines from running into each other, put a double space at the end of them. Again, if you need to remind yourself any of that, remember we've always got the Markdown quick reference guide that you can have over here, manual line breaks, and the line with 2 or more spaces. Okay, so just a reminder of that. All right, so back here, so we got what else? We got QR for quantitative reasoning. And the quantitative reasoning, that again was a normal distribution, but this time it had the mean for score for there was 584, and the SD was 151. Okay, so if you go back to our intrepid student here, just looking at the raw scores, you might be, unwittingly duped into thinking that she did better on her, let's see, she got a 620 on her verbal reasoning and a 720 on a quantitative reasoning. So you might think, just looking at the raw scores, that she did better on the verbal reasoning than she did on the quantitative reasoning, okay? So let's go take a look and find out if that's true or not, all right? And the way you do that is by looking at z-scores. You don't just look at raw scores because you're trying to compare, in this case, how she did with relative to the other takers of the test. When you take the GRE, they give you back where you fell, what your percentile was compared to the rest of your peers on your particular score, okay? So they say draw a standard normal curve distribution and mark these two z-scores. So first they say, what is her z-score on the verbal reasoning and on the quantitative reasoning, and then draw a standard model distribution to give those two. All right, well, we can do these by hand, which I think I'm going to go ahead and do that simply because it's good to get some practice doing those. But of course, we can also insert a chunk and actually get R to do the calculation for us. So we'll do both, okay? So I'm going to come over here and open an R chunk. And let's go back for a moment to the whiteboard real quick and take a look and remind ourselves how we actually do these, okay? So let's get a fresh whiteboard here. Go ahead and clean this one up. So how do we actually calculate a z-score? Well, remember that z is equal to x minus mu divided by sigma, okay? So in the case of the verbal reasoning, that tells us that what? Well, she scored a 620. So that's going to be a 620 minus the mean, which was 462, divided by the standard deviation, which was 119. And then on the quantitative reasoning, she scored a 670, and subtract that the mean of 584, and I'm going to divide that by the standard deviation of 151. Okay, so notice this notation, the way I wrote this down. This is called inline notation. I'm not using the long fraction bar like is in the formula up here. Notice up here I've got this long fraction bar. We've got to be careful with this thing. This thing is actually a no good rotten dog meat, okay, because it's doing double duty. Not only is it inferring division, but it is also inferring a grouping symbol. Well, on RStudio or my calculator, I have to infer division, I have the backslash. And so in order to get the backslash to work appropriately, I have to put in those inferred grouping symbols explicitly. In other words, I need to put the numerators in parentheses, okay? So, excuse me. So make sure when you're getting rid of this bad boy right here. In other words, when you're getting rid of that fraction bar, that you know that you have to put in explicitly the grouping symbol that was tacit in that fraction bar. Okay, so let's go back to our R chunk now, and let's go ahead and type those in, okay? So back over here to RStudio, and let's go ahead and put in the 2 here. So we're going to put in, type in just how I had them there. So 620 minus 462, and then divide that by 119. Of course, you could do this on your calculator also if you wanted to. But since we're going to have to type it up in RStudio anyway to put our answer in here, might as well let it do the work for us, right? Oops, my parenthesis in there. So 670 minus 584, and then divide that by 151. Okay, and now as usual, we can go in and execute just that chunk so we can see what is going on. So we'll run the current chunk, and we get the 2 Intrepid z-scores here. So let's come down and put in here. So for the verbal reasoning, that's a her there really, her z-score was what? Well, it was 1.328. We'll go out 3 places. That's plenty. And for the quantitative reasoning, her z-score was, let's see, what was it? It was 0.570 if we round off to 3 places, okay? All right, so which one did she do better on? I just want to think about this for a minute. That's going to come up here in a question. But at first, like we said, we might have inferred, since the larger of the 2 scores was the quantitative reasoning one, the 670. But if you take a look at her z-score, the larger z-score was actually in her verbal reasoning, not in her quantitative reasoning. So they ask us to plot these on a normal distribution. The hand-drawn stuff you do not need to turn in, okay? But I still want you to do it. So you don't need to put it into your R Markdown file. You can get R Markdown to do what I'm about to do, but the amount of code to get it to do it is not worth it. So I'm just sketching it by hand, and I'll trust you that you did it, okay? All right, so let's go back over to the whiteboard for just a moment here, and let's go ahead and put in our numbers here. And then we'll put in, me of very little memory. So let's see, what are 2 numbers? They are, let's see, 1.38. So 1.378. And then let's see, what do we got for? It's 0.570, okay? All right, now they ask us to take and put these on the 2 distributions, okay? In other words, they want us to come in and basically draw the distribution of verbal reasoning. So this is our verbal reasoning distribution here, and we know that it's a normal distribution with a mean. Ooh, I have an inco there, don't I? I wrote down 46, and I meant to write 462. There's a 2 in there, really. So in the verbal reasoning, we know that the mean here was 462. And the standard deviation was 119. So that's back from part A there. That's what the model looks like. And so that means that the mean right here is at 462. And we know that 1 standard deviation above or below the mean happened at the inflection points on our distribution. So her z-score was 1.378. So that means that the 620 is going to fall roughly about there. Okay, so that's about where she fell with respect to her distribution. And we know that the distance from there to there in units of standard deviation was 1.378 standard deviations above the mean, okay? So in other words, we know that the z here was equal to 1.378. Okay, so let's take a look at the quantitative reasoning. So under quantitative reasoning, if we were to make a sketch with that, so we know that this is again a normal distribution with a mean of 584 and a standard deviation of 151. So the mean right here is at 584. Her score was a 670, and we notice that that's half a standard deviation above the mean. That's 1 over to there. So her score would be roughly right about there is where the 670 falls in this distribution. Okay. All right, so as we can see, I mean, roughly these distributions are obviously different shape, but we can see that her verbal reasoning score fell higher in the distribution than her quantitative reasoning did when compared to her peers, okay? All right, so let's go back to our studio here, and it says, what do these z-scores tell you? Okay, so that one is just pretty much a canned answer here. It's just they give they give the number of standard deviations above the mean. That's all they're looking for there. They weren't looking for anything more glorious than that, all right? Okay. And then in part D, they say relative to each other, which section did she do better on? Okay, we know that her z-score was 1.328 for the verbal reasoning, so she must have done better in the verbal reasoning than she did on the quantitative reasoning. So relative to the others, which section did she do better on? She did better on the verbal reasoning part of the exam. Okay. All right, cool. So find her percentile scores for the 2 exams. All right, well, to do this, we're going to have to go in and insert a chunk. So let's go and insert a chunk. And then we've got to remember how to go in and do p-norm. Well, why? Well, let's think about this for a second. What do we got going on here? Well, we know that we have a position on the z-axis, and we want to know what the relative percentile was corresponding to that. Okay, so let's go ahead and go over to the whiteboard real quick, and let's draw that. Okay, so oops, get my palette in the way here. Sorry about that. Where are you? So what we know is in the first situation, ooh, nice thick one here. I'm going to turn my pen down just a smidge here. So we know we have 2 normal distributions, and let's say that this one was the verbal reasoning distribution. If this was the verbal reasoning distribution, then we know back up here from our previous work that it was normal with 462 by 119. Okay, so in other words, the mean was 462 and the standard deviation was 119. And then if we draw the second one, just to go ahead and get her done here right away, for the quantitative reasoning. Okay, so quantitative reasoning, again, this is a normal distribution. And if we go back and check real quick, because remember we did the model here, we said that the model in that one was a mean of 584 with a standard deviation of 151. Okay. So what we did, though, is we converted both of these into z's, but we don't really need to do that. Okay, now if we were using tables, we would have had to. If we would have had to have gone and convert both of these into standardized distributions and use the z-table, but since we're using RStudio or R to actually do the calculation, we don't need to do that. Okay, so here's the mean here at 584. That's what mu is equal to, and then here the mean is at 462. Okay, so let's go take a look at what our intrepid student did in terms of her scores. Remind ourselves here. So let's see, what did she get? She got on the verbal reasoning, she got a 620. So let's go ahead and mark that onto our distribution. So 620 about up here in this neck of the wood. And so what would her percentile be? Okay, well, we're going to remember that when we're talking about percentiles, we're talking about how many people fell below her. So the percentile, the value that we're going to be looking for in the percentile, is actually going to be this region down below here. It's going to be left tail, okay, which is nice because we know that p-norm creates a left tail. And similar sort of situation going on with the quantitative reasoning. Get my colors back here, my color palette. And so we come back around over here and we take a look and we say, well, look, by the way, we see that she scored, what, a 670 on that one. So 670 would be, say, about there-ish. And again, if we were to shade in the region, this region right here would be the corresponding percentile for those, okay? So how do we actually do those calculations? Well, to figure out what this area right here is, this is going to be P norm with the mean of 462. Whoops, my bad, excuse me, that was a mistake. I don't want to put that first. We want to put her score in first. Then we'll put it in the 462. Sorry about that. So put in her X value, which was 620. Put in for her mean value, which is 462. And put in her standard deviation, which was 119, okay? Let's kind of try and see if we can make that look like a 6. That would probably be a good idea, wouldn't it? Yeah, there we go. Okay, so let's go ahead and get that one. So let's go over to RStudio and type that in to our chunk right here. So we're going to put in P norm, put in the value of X, which was 620, put in the mean, which was 462, and we'll put in her standard deviation for that particular exam, which was 119. Okay, so let's go ahead and just execute that chunk real quick. And we see that she did pretty darn well, as we had already stated in an earlier part that she was in the 91st percentile if we round off. So let's go ahead and answer that question right away. So she was in the 91st percentile. For the verbal reasoning, right? Okay, so let's go check out and see what she's going to be for the quantitative reasoning. Well, again, that's going to be P norm. I'm going to forego going back over to the whiteboard if you don't mind. And I'm going to put in 670. And we'll put in her mean, which was 584. And the standard deviation, which is 151. Okay, let's go ahead and execute that chunk. And you see she got in the 72nd percentile again, so that bolsters what we had said in our previous stuff, is that she didn't get quite as good in the quantitative reasoning as she did in the verbal reasoning. So she was in the, we'll give her 72nd percentile. For the quantitative reasoning. Okay, cool. All right. So let's see, what's the next one? It says, find what percent of the test takers did better than her on the verbal reasoning section on the quantitative reasoning section. Well, let's go back to the whiteboard for just a second and see if we can answer that question sort of graphically here. And then we'll go ahead and do just a little bit of arithmetic to see that answer. Well, take a look. This region up here, actually, let's make that green. I'll make it so it stands out, a little bit of contrast there. So this region right here is the percent of people that did better than her on the verbal reasoning, and this is the percent of the people that did better than her on the quantitative reasoning. Well, what do you know about these red area and the green area combined? Well, those have to come out to 1, don't they, right? Okay, so if we come back here to RStudio, and we can go ahead if we want. I mean, it's probably not a horrible thing to do to enter in a chunk here, just so we've got the numbers. Insert chunk. And I'm just going to go in and I'm going to kind of just cheat a little bit. Not cheating, it's just working kind of smart here. I'm going to copy the previous P norms we did, and I'm going to make them 1 minuses. And by doing so, I'm going to get the amounts that were left over, in other words, the parts that were in those areas. And we see that that's about 9% roughly, because what did we say? She was in the 91st percentile. And about 28%, because we said she was in the 72nd percentile. So I mean, you obviously could have done those in your head, but it's kind of nice to see that it actually makes sense in R also. So there were 9% above her in verbal reasoning and 28% above her in quantitative reasoning. Okay. So what percent of test takers did better? Oops, my bad. I got those in the wrong spot here, didn't I? Let me just move everything. I just kind of moved everything, put stuff in the wrong spot there. So just take a second here to fix that. There we go. My bad. There we go. Okay, cool. All right. So last but not least, they say explain why simply comparing the raw scores from the two sections would lead to the incorrect conclusion that she did better on the quantitative reasoning section. I already actually answered this one. It says we need to use the z-score to see how far from the mean her scores were relative to her peers. The raw scores don't tell the story. In other words, what they do is they don't take into account the mean and the standard deviation of the distributions of which she got her scores. Okay. All right. Well, that finishes off this problem. That finishes off exercise 3.3, and come back soon, and I'm going to do exercise 3.5 for you.